Hello, and good evening. Today we have two really awesome guests and two really awesome topics. The first topic is about performance optimization in Angular, and it will be presented by Alex, who is already next to me. Hi, Alex. And the second topic is about AI, LLM, and MCP. A lot of abbreviations that cause a lot of traffic nowadays. And we will try to combine it with design systems. And for this, our colleague Andreas will join us in some minutes, who is really deep into both topics. He has quite a past with design systems, and he's now full into AI. But before we start, I want to tell you a little tiny bit about our sponsors. And I have a little tiny job announcement for you from one of our sponsors. So let me share my screen. And those are the slides with our sponsors. So big thanks to all the companies that make all of this possible. Not only the online meetups, where we have now more than 460 participants today, but also all the other on-site meetups. For instance, this fall, we will do a bigger on-site meetup in Graz, Austria. So in this sense, big thanks to Bearing Point, who is not only a sponsor, but they will host us next time in Graz at their nice, beautiful, modern new office. Big thanks to GUID-New, our long-term partner. GUID-New is implementing software with .NET in the backend and with Angular in the front end. Also, big thanks to Aurena Tech, also a big player on the Austrian market when it comes to auctions, online auctions. And also those guys here, perhaps you have seen them, Angular Architects, which is more or less the company I founded and where I work together with a lot of nice colleagues, trainers, consultants, developers, with focus on both architecture and Angular. Saying this, we have several workshops. Our best seller is our Angular architecture workshop. You can book the tickets now online, but you can also book it as an on-site or at least a dedicated company workshop. And there is another one, Modern Angular, which is now rebranded to focus on signals and the resource API. Because we have seen that signals and the resource API are the two features of modern Angular most people are interested in. And it will shape the future of Angular. You also have to apply reactive thinking. That's why this is a very important topic. So check out our workshops on our website. Before we start, I have also this job announcement for you, a job announcement from our partner GUID-New. GUID-New is searching in the German language area, Germany, Austria, Switzerland, for a senior full stack developer, which means in this case, you know .NET and you know Angular. And you know, as GUID-New is an Austrian company, they have to put the minimum salary on the website. There is a law in Austria, and you can see the minimum salary here. So it's really the minimum. And yeah, I think it's not that bad for a senior developer. I know huge companies paying less on average. So if you are in the German language area, if you want to do this job, you can also do it in a hybrid way, then write them a message. Okay, and now it's time to close the recursion. Now it's time to hand over to Alex, who will tell us a lot about performance. Alex, stage is yours.
Thank you, Manfred. Yeah, hello from my side, and welcome to our Angular Meetup, online meetup. I want to talk about deferrable views and incremental hydration in Angular. Let's get started. So why is performance optimization important for us? There are a few reasons why we should do that. It's, for example, a better user experience if people don't have to wait for our app to load. It can be beneficial to our ranking when people still use search engines. Maybe nowadays they switch to AI more often than not. However, it can be good for the traffic in general and for other important metrics like the bounce rate and, of course, the conversions. So a lot of reasons to do performance optimization, but the most important for me is it's a lot of fun. At least that's what I think. Today's topics will be the deferrable views. Those have been around a while. I assume most of you have heard of that. They have been added to Angular in version 17. And the other topic is incremental hydration, which actually builds upon deferrable views. That's why we talk about them both. Incremental hydration has been introduced in Angular 19 as developer preview, and is now can now be considered stable in Angular 20. So it's production ready. Yeah, just quick about myself. My name is Alexander Thalhammer. I'm from Graz, Austria. So I speak German and a little bit of English. I'm a web developer for a long time. And since 2021, I joined Manfred's team from the of the Angular architects. And since then, I'm a Angular coach and consultant and trainer, of course. So we do very good workshops, at least that's what I think. And my favorite topics are performance, accessibility, and this new thing that I call best practices, where we do a little bit of everything. Also modern Angular, migrating to signals, also performance relevant related topics, accessibility, and much more. Even some AI code generation topics. Yeah, about the agenda again, we talk about deferrable views and incremental hydration. I want to give you a brief and quick introduction to both topics, and I will show you a demo to both topics. By the way, I forgot to post the link to the chat. Let's go back to the first slide. So you can find everything on this page, and you can find the source code here if you want to look at the code while I'm talking about it. Okay, you find the two links in the chat. The slides are to be found as well on the lxt.dev. If you want, you can download it from there. Okay, let's go back here. So let's start with deferrable views. Deferrable views built upon standalone components. By now, you should really already have migrated to the standalone components, because in the future, the Angular framework is going to build upon standalone. Many features like deferrable views and incremental hydration, it's necessary to use standalone components. What is defer? It's actually an alternative to the router-based lazy loading. Many Angular developers, Angular teams used the router-based lazy loading, where you have in your routes configuration the load children, either for a module or multiple routes, or the load component for a single standalone component. This works, of course, only when you have a route for that component. And deferrable views are an alternative to that when you don't have a route. So sometimes you have a widget in your application and you want to lazy load it, or any other component, and you don't have a specific route for that. That's exactly when you want to use deferrable views. So yeah, some examples here: widgets, large or charts, or tables with large third-party dependencies that can be then lazy loaded. It also forces client-side rendering. So when you using server-side rendering, you can force client-side rendering for a component when you put it into a deferred block. So that's a trick to enforce client-side rendering. And one important takeaway is it's actually not so suited for above default content. Above default, if you don't know the term, is everything what you see in the initial screen. So consider a smartphone device. All that you see on the initial load is above default, and all the other things that you might scroll to are then below the fold. So the fold is the bottom of the initially loaded screen. Let's put it like that. And actually, deferrable views are not suited for above the fold content, but perfectly suited for everything below the fold, or maybe everything that's not really relevant for the initial load. When you have something above the fold, then of course you need incremental hydration, which we will talk about in a few minutes. What else is there to know? There are some triggers. I'm pretty sure you have heard of them. One of them is called onViewport. This trigger basically works similar to the ng optimized image directive. Whenever a component is reaching the viewport or a little bit below that, so when it comes into the fold area, then it's being loaded and the loading is triggered. Here's a list of triggers, but of course, yeah, I don't want to name them all, but yeah, there are a few. The most important probably is viewport, hover, and interactions, or R. And then there is also the prefetch function. A prefetch works like the preloading strategy when you use router-based lazy loading. You can, for example, defer on viewport and prefetch on idle. That means whenever your application is fully loaded and in the idle state, then this component will be prefetched, and then when it reaches the viewport, it can be loaded even faster. There are also some additional things you can use together with defer. You can show a placeholder before the thing is loaded, a loading state when it's being loaded, and if there is a connection error, you can show an error. But typically, I've never really experienced an error state except when testing without internet connection, of course. So the thing works generally, but you can use the error state if you want. To conclude, deferrable views, they can be nested, and be cautious when you use deferrable views above default to avoid layout shifts. So whenever you use defer in the initial loaded area, then be cautious to not create layout shifts. Layout shifts mean that your content shifts, and this is generally considered a very poor user experience, so you should avoid that. You can, of course, combine deferrable views with server-side rendering, and yeah, so the placeholder will be rendered on the server, and as I mentioned, the defer block itself is enforced to render on the client side. Okay, so very quick introduction, as I said. Now let's quickly jump to the demo that I've prepared. Again, you can yeah, check out the demo on GitHub. The link is in your comments section of the stream on YouTube. And yeah, I have here the demo component, and I've yeah, basically 4 defer blocks. One is being loaded on immediate. That means immediately when the component is initialized. One is loaded on hover, but prefetched on idle. And the third one is on interaction. Interaction means, for example, click or key down. And the fourth is loaded after a timer. And so basically you have your add defer and then a trigger. If you don't add a trigger, the default one is on immediate. So basically we could leave that away, but let's just keep it there. And you can also use multiple triggers. So I can, yeah, basically add as many triggers as I want here. Yeah, and additionally, I can say prefetch on idle. So whenever the app is in idle state, everything else has been loaded, then this component will be prefetched. Prefetching means load the JavaScript bundle, but do not yet execute it, okay? So that's what prefetching is. And now we have, I've served the application. By the way, if you serve the application locally, you should use the no HMR, no hot module reloading flag, so that the defer properly works. And now you can see the action. This one is loaded immediately. This one is loaded after 4 seconds. And the top right one is loaded when I hover it. So let's go to the network tab quickly. Yeah, it's already prefetched. I tricked myself. So let's remove that for now. Do it once more. Okay. Yeah, you saw this chunk has been loaded, and that one will be loaded when I hover it. So now the chunk is loaded, and it's already being displayed in the screen. And the last one on the top left is on interaction. So I have to click here to display it. So this is just a playground for different triggers, basically, to demonstrate how these triggers work in action. Yeah, hello, Andy. You're here finally. Okay. So let's go to the next part. As I said, in this case, typically we would use this for below the fold. So if you have a small viewport, maybe that would work better. But if you have the components in the above the fold area, you should actually use incremental hydration, and that's what I want to show you next. So what is incremental hydration? It's actually the future. At least that's what I think. So it builds upon the Angular hydration, the defer block, and event replay. So those features, it's pretty interesting how these things how this thing evolved. Hydration was added in Angular 16. Deferrable use were added in Angular 17, and event replay was then added in V19. Event replay basically during the load, when you interact with something that's not fully loaded, event replay will catch that click event or key down event and replay it after the JavaScript has been loaded, so that no user interaction has been lost. So these 3 features altogether enable incremental hydration, which is a really good feature, and I think everybody should try it and play with it, because it's really leading to super loading performance with Angular for the first time, in my opinion. Yeah. So yes, as I mentioned, defer blocks should be used below the fold when you have content above the fold. So in the initial view, then you should use incremental hydration, because the main content instead of the placeholder will then be rendered on the server. So another thing that I didn't emphasize or mention yet, the defer blocks, they work without server-side rendering. You can use it in any application, but for incremental hydration, of course, you need server-side rendering. So that's, maybe one drawback. But whenever you have a setup with server-side rendering, then you're ready to go. The triggers are the same, so you can reuse the knowledge from the defer blocks. You can use the same triggers for incremental hydration. You have the on triggers, on immediate, on idle, on viewport, on hover, on interaction, and so on. You can create your own triggers with when, for example, a Boolean signal function. Oops, should be a C. And there is an additional trigger which you don't have in deferable use, and that's never. So never is for static content where you don't need any interaction. So if you have any widget or any chart that doesn't have or need JavaScript interaction, you can use that trigger, the never trigger, and then it will be fully server-side rendered, and a static HTML will be sent to the client, and that's it. No need to hydrate that block or that component. So as I said, this is a really good solution for above default content. It can also be used for below default content that's dynamic, so it changes. And yeah, there are multiple scenarios, products in an online shop, forms, interactive tables. For example, you can provide a static HTML version of the table, and when the user clicks into a cell, then you can really hydrate the table and then focus into the cell. So a lot of possible scenarios, and a good addition to the deferrable use, which should be used for content below default. Okay, so let's go to the second demo then. I need to, yeah, switch the branch. Okay, let's make sure that the right version is being loaded. Okay, so now in this demo works like that. Whenever the component is hydrated, the image will be in color, and before hydration, it will be gray and white, as you can see here. So when I hover here on the top right snowboarder, it's being hydrated. The top left component is never hydrated, so it's not possible to hydrate it. The bottom left is, I think, on click, and the bottom right, actually, I don't really know. Let's look in the code. Yeah, those two are on interaction. And the first one is hydrate never. Yeah. Okay, what else can I show you? So if you look in the Angular DevTools, you will see that the first component on the top left, what is it called? App-Victor de la Rue. It's not visible here because it's not considered an Angular component, right? It's just static HTML, server-side rendered, and this component cannot be hydrated because there is no hydration, right? Then app Naomi, this one is already hydrated. You see the drop here, and the other two are not yet hydrated. So again, we can hover here or click on it, and then those will get hydrated as well. So most of the time, you don't have the feature that your components are black and white while they're not hydrated yet. And then you can work with these Angular DevTools, which is pretty cool. All right. Okay, I think that's more or less it. Let me come back to the slides. So yeah, let's do a quick recap. Why should you use server-side rendering and incremental hydration? You get faster Angular applications. Largest content for paint and interaction to next paint are just two metrics that can be improved drastically. And of course, that results in a better user experience and happier users. And I think also happier developers, because at least for me personally, doing performance tweaks is a lot of fun. And yeah, as I mentioned, I really like it. I also do some workshops about it. Yeah, final conclusion: improve your initial load with deferrable views, and if you can, with server-side rendering and incremental hydration. Of course, also use the other things like static site generation, which is called pre-rendering in Angular, if you can. Deferrable views are best suited for below the fold content. If you take one thing away, then that's that. And incremental hydration is the best solution for above the fold content, which doesn't have to be hydrated initially. Yeah, try it, play with it, have fun with it. And the final question: why aren't you using it already? Yeah, as I mentioned, I think it's really fun. I have some resources here. Final slide is this. Oops. Yeah, again, click the link. I posted it in the comment section. You will find the slides there. You will find the source code on GitHub. And of course, feel free to contact me via X. I'm still on X. And you can also find other channels to contact me if you click that link. So yeah.
Awesome. Awesome. Big thanks to Alex.
I'm open for questions.
Currently, I don't see any questions. Oh, there is one. Does defer work with server-side generation?
I think it's static site generation. Yeah.
Yeah.
So yeah. So when you use server-side rendering or static site generation in combination with defer, it works like that the defer block forces Angular to render the component, or maybe there are multiple components in that block. They are forced to be rendered on the client. Okay. So if you do static site generation, it will not be rendered on the server, but instead the placeholder will be rendered on the server. So the placeholder will be in the statically generated HTML, and then that defer block will be rendered in the client. So it's a good, actually it can be used if you want to use static site generation. Let's say you have a product item and the price of the product depends on the user, right? You have different user groups like default customers or wholesalers who get the better price. And then you can render the price tag on the client, but the rest of the product page could be rendered statically on the server. So you can use static site generations in more scenarios combined with deferrable blocks for the user-dependent content, right? So everything that's the same for all users can be can be pre-rendered, and then the user-dependent content can be put in a defer block. That's how that works.
Awesome. So I don't see any further questions, but perhaps you have a good question, Alex. What is the best question you can think of? If you would not sit here, but in the audience, which question would you ask yourself?
Yeah, what I think is the big question is, I had the slide. Why are so many people not yet using server-side rendering and incremental hydration? And I think it's I don't know. I think it's a knowledge problem. I think people don't know how easy it is nowadays to set up server-side rendering. And maybe they didn't read the news with the latest Angular updates, or let's say the last 5 Angular version updates. It became or it got much nicer, much better from the developer experience and from the user experience in the versions between 16 and 19. Actually, 20 didn't change so much in my opinion. So yeah, I think much more people should use it. And I would really like more feedback and more experiences with that.
Awesome. One person, Markus, is saying it's a Java backend problem. Yeah. So if you only can run Java in the backend, then it indeed is, I guess.
Yeah, Markus, you can still use static site generation. So yeah, when you don't have a node server environment, static site generation can still be used. All right, yeah, Markus, you're already asking the question that I'm already answering. Yeah, no, you can use server-side rendering. I do actually use Nginx servers, but I still use server-side rendering. All you have to do is fire up the server-side rendering locally when you create your build, and then you can create you can pre-render pages, and those pre-rendered pages, they are just HTML. You can upload them on any web server. Doesn't have to be a node server, and you're ready to use server-side rendering with static site generation. Yeah, many people also, thank you, Markus, for asking that question. That would actually have been another really good question. Yeah.
And perhaps it's also a good possibility to advertise for a backend for front end that could be implemented with Node.js, of course, and sitting between your front end and your real Java backend.
Yeah, the deployment, yeah. Yeah, for static site generation and for incremental hydration, you don't really need a node server. That's what many people don't know. People think they have to have a node server environment to use server-side rendering, which is actually not true at all.
Awesome.
Okay.
So big thanks to you, Alex. This was really a nice presentation, also nice example. I especially like the visualization of the hydration using the grayscale stuff and the really
I like that too.
So big thanks for this. And now we can switch over to our next colleague, Andreas Wissel. Hi, Andreas.
Hi,
hello. Very nice talk, Alex. I only saw half of it, as you already noticed, but I always like seeing better user experience. It's great.
So Andreas is really into a lot of topics. I don't know a lot of people who are in several topics that deep. He is a real good architect for Angular, but he is also capable of doing visual things. That is not an insult for the eye. When I do visual things, it's always an insult for the eye. But in Andreas' case, it really looks beautiful. He has a lot of knowledge around design systems, not only the aesthetics, but also things like UX and the whole process around it. And today he will combine it with AI. Is that right?
That is right. Thank you for that very nice way of phrasing that I get bored really quickly. I think that's the real secret here. I like to try new stuff quite a lot, and it took me on quite the journey in my career so far.
Nice. Okay, so here we have your slides, and yeah, stage is yours.
Thank you. So today we will talk about MCP servers, and we will do so looking at the example of getting from Figma to code with AI. So for the past years where I've done my workshop on design systems, I always got the question, would it be possible to automate this process of component generation? Now that we have a nice design system, we have specified all of the components in this design system, why do I even have to code anymore? And we saw the first steps of this process quite some time ago. So I think last year, it was at the beginning of last year, I released a plugin for Figma that would extract component information from there and all of the properties that you have in Figma, throw that at GPT-4 at the time, and just try to do its best to figure out how to build a component from that. And as you can see on my nice slide here, we have now reached the next evolution of that. And why I am so interested in that is because I'm the head of product and AI at Facelift, which is a company that's building social media management software and communication orchestration software. So we face all of these challenges on a daily basis. And I, of course, when working in product, I love anything that makes us quicker when implementing a product. And I would like to kick things off by having a quick state of AI in the mid of 2025. So let's first of all talk about where we're coming from. So we're coming from a world that is changing very fast. You can see this chart here. It only goes to the end of 2022, but I like the illustration that we see here, that models are growing exponentially fast in parameters, intelligence, and context window size. You know that already, probably seeing all of the models that are out there today. They're being released super fast, and we're still not seeing a substantial slowdown in the release cadence that they have. And we also have new ideas like sub-agents, tool use, reasoning models that improve the output quality dramatically, really. And we can see that the frontier models like Claude and whatever the most recent OpenAI model is at the time, I think they're not really great at naming things, but right now it's O3 Pro or Google's Gemini models. They're really doing a very great job at keeping context, at just executing on what you tell them, enriched with context information that you give them. And it's evolving even faster than we anticipated. So in 2019, we believed that AGI, or artificial general intelligence, so a system that would be as smart as a human in any discipline, would be here in 80 years, so in the year of 2099. Then the advent of GPT-3 happened, and OpenAI put it out there in the world for us to see. And you probably all had this ChatGPT moment, just like I did. So when they released that, I have decided this is going to be the next big thing. I really need to get into this. And this has been 4 years already now. And back then, we believed it was going to be 50 years. And as models evolve, you can see this curve it's steadily going back. So now researchers believe that if the forecast is well tuned, it's going to be here in 2030. And if the forecast error continues at the same pace that we have seen it so far, it's going to be here next year, which is quite crazy, to me at least. And we can see that in the top 20 models that we have today, so you can see here a chart of the top 20 models that are being evaluated by Artificial Analysis, which is a very nice site, by the way, if you're trying to stay on top of what's happening in the world of LLMs, go ahead and visit it. But you can see that no model in this list was here before the winter times of 2024. So I think the oldest model in here might be GPT-4o, which was released in November of 24, and it goes up to models as recently as O3 Pro, which was released 2 days ago. And we can also see that the intelligence of these models is steadily increasing, and the age of reasoning is also here. So we now see reasoning models out there, and they're better at what they do than non-reasoning models. So they actually started thinking, or at least they emulated thinking in a way that we can see it makes them smarter. So it takes multi-step approaches before answering. It takes agents for specific tasks. You have these mix of expert models out there. You have the multi-step approaches. You have the agent models out there, which are really, really doing a great job at answering our most burning questions. And we can also see that these frontier models, they're trading punches. So Claude used to be without competition when it comes to coding, but then O1 got introduced as the first reasoning model from OpenAI, and it improved on coding and math skills, reducing hallucinations, because it really started double checking what it said rather than just guessing the next word in the chain or the next token in the chain. And O3 Mini continues this trend with great reasoning skills with a very competitive pricing. So you can also see these innovations, these foundational changes, they happen, but they're quickly being followed up by a dramatic reduction in price, by a finer tuned model. And even as the models, they get more information over time, they get more efficient at what they do. So when we see the big providers testing their models, they keep reducing the price as well. And after all this happened, Claude 3.7 greatly improved on one-punch coding results. So you might have seen the whole vibe coding trend out there, that you just put in one prompt and the model will just spit right out the result that you're looking for. While Claude 4 is already betting big on sub-agents. So you see there's a continuous trend happening in model development where you can never really say, oh, this is going to be the one model that we're going to use for the next few months. So you really have to stay agile, and you really have to test continuously what is the right model for your use case, and to find the models that also work in your consumer grade applications, right? So we can also see that frontier models, while they're becoming widely available short time after initial release, we can see them working at a very reasonable price. Again, here is an example from last year. It's for GPT-4 or 4 Turbo, 4.0, and so on, respectively. And you can see over the course of roughly 1 year, a little bit more than that, you get 50% cheaper inputs and 33% cheaper outputs, which is made possible by smaller models that introduces consumer-friendly pricing that drops over time as models evolve and become more efficient over time. And after all of this, we also saw the advent of AI agents. So you've probably heard this before. It's a really, really big buzzword, and I think it's rightfully so, because they enable autonomous use cases that weren't available before or weren't even possible before. They were only possible if you put a lot of effort into it as well, to manually combine all of these systems, because what they do is combine memory, context, API calls, and communication with other autonomous agents or systems to augment human tasks and automate repetitive tasks with reasoning and context. So in this little graphic here on the right, you can see there's actually quite a bunch of things that agents do to be more efficient at the tasks that we delegate to them, and to pull in more information and also live information. So something like GPT-4.0 accessing the internet, that is already agentic in a way, because it will kick off a search agent that will bring back the right results and present this to you. And this is mostly the de facto standard nowadays. And we also saw with the same advent, one of the fastest growing software as a service companies in the world ever. So Cursor, you've probably heard of that as well. It's one of the AI first IDEs out there. It grew from 1 million ARR to 100 million in 12 months, which is it's mind-boggling. But also VS Code is catching up super fast. So also here I want to say, don't bet on one tool, because the space is evolving so quickly that we need to be able to try new things every now and then. Of course, in your day-to-day work, rely on the proven systems that you already have. But I think we're back to those times, just like the good early internet days, which, yes, I was there for that, but I was still very young, and I was doing nothing but going to school and tinkering with the new stuff that happened on the internet, because I thought it was super, super exciting. And when seeing all of this, I also want to say AI won't replace us. I also saw a nice comment in the chat, AI won't be late to a meetup, so sorry for that. But I want to say AI won't replace us, but our jobs are changing. So to speak in images, what is happening for us coders here is that we were working in factories with a steam machine. So we had this one layout where you had a central steam pipe going out to all the workplaces, and everything was revolving around that. And then someone came along and invented electricity. And with that came totally new possibilities, new situations arose where you could do things you couldn't do before, and totally new perspectives emerged as well. And as we all know, we love electricity today because it made the internet possible, it made programming possible, and it was just a great invention all around. And I think the same thing is happening with AI. So it's changing the way we work, but it's not replacing us, for now at least. So let's see what happens in the next year. But I really deeply believe that everyone should adapt this in their everyday workflows, because it really drastically increases the output of every one of us. And the main thing that I want everyone to understand here is that we're now seeing the worst point in time that AI is ever going to be. So it's not going to get worse from here, it's only going to get better. And that's why I'm saying AI is here to stay. So we want to unlock all of the potential that is hiding behind this. And I want to dive quickly into how we can do that. So first of all, a little primer on how do we actually work with AI when coding to make it more efficient, and how can we implement it in everyday work. So one thing that is really, really useful is to plan ahead. So think slow, act fast, because planning is half of the way there already. So maybe you've already seen these prompting guides, you've seen the frameworks that are out there, you've seen the support files, the cursor files, and whatever is out there, which is basically universally true for every tool that is out there. What we want to do is plan out ahead of time what we want to do, which, by the way, you can also do in tandem with the agent. So they're getting really, really good at taking your inputs, your instructions. And I want to say they have to be very clear, but even this is getting more foggy now, because agents are really good at understanding what you're trying to say. So you don't have to be as clear anymore, but you can let the agents come up with it. But in the end, what this is about is to set your expectations straight and chunk pieces of information to not overload context windows, because this in the end is a productivity killer. This is where you're wasting a lot of money. This is also where things get slow and the AI gets confused. It starts hallucinating. So you really, really want to be sort of a conductor of an orchestra of agents, or you're there dispatching all of the right things to the model to let it do the busy work, the typing that we don't really need to do anymore to that extent that we have done it before. So nowadays it's more about the thinking rather than the executing, which I think, by the way, is a great thing. And I want to say you can plan a lot of things ahead of time, and you can share your brain with your assistant. So as an example, you could talk about database designs. You can talk about user journeys or task breakdowns, and you can talk about project requirement docs, which outline the full project ahead of time, defining all of the things that go into building this project, which ChatGPT, by the way, it's very, very great at composing these. And you can also be lazy in a way that if you hate building UIs, unlike me, I love building UIs, but also I love to use tools like V0 or Lovable that can help me quickly prototype UIs, come up with real code, in this case, sadly, React, which is, I think, just because it's it uses a little less code to come up with similar results, and there's less concepts to learn, so it's easier for the models to understand what's going on. And also, if you're having trouble to get nice code out of your editor, you can use agent folders to fine-tune the output and document the process so that the agent doesn't lose track of the task you're trying to get done and what you learned along the way. So if you find yourself debugging the same thing over and over and over again, what you can try to do is let it output those common bugs into a markdown file where it will resort to that to think about, have I solved this before, and was there a good solution to it? Or if you want to include any external library or your own library, you can add documentation in the context as well. For example, in Cursor, you have this nice docs command that will actually start and search in the documentation that you link to it, and try to consume that. And also there's search agents, which are really nice to really understand what's going on in a code base, and also finding files where you just describe to it what you're looking for, and it will just automatically turn up. And the good thing about this is that documentation enables AI, right? So AI coding assistants and the agentic systems, they both thrive on context given by data. And this is really a thing where design systems come in nice and handy, because whoever heard me speaking about this before is not surprised by the fact that component libraries or design systems are mainly there for providing a well-documented and structured system, which is, of course, fantastic for AI. And building and maintaining a component library will increasingly be taken over by AI, in my opinion, and will leave your productivity for strategic architectural and product work, which again, I think it's a really, really great thing, because coding can be fun. It can be a nice pastime, but the really important work is all about how do we write architectures that scale? How do we find the right strategy for our product? How do we do the actual product work of implementing those features rather than keeping a component library up to date and doing all of the nitty-gritty work in the everyday work. And as a conclusion to that, context is king. The more context you give to LLMs, the better they will perform, full stop. And top performing assistants like Cursor, for example, they work with context retrieval systems as well to make this even easier for you to have, excuse me, something like RAGs or retrieval augmented generation, where it will actually go and retrieve all the information for you from documents, or vector DBs where they embed actual information in your LLM, or you even have code search agents. You have something like MCP servers that solve these cases for you. So it tries to embed this knowledge about your code base into the LLM context. I'm saying LLM context here rather than the LLM itself, because depending on which of these context retrieval systems you use, it will end up in the actual model or just the context. And what it really does is it will map code bases, and this is true for existing or evolving ones. So whether you start from scratch or you work on an existing code base, this is a great way of making it easier to work with an agent on your code base. So imagine you have a project in front of you right now, which might consist of a big NX monorepo. You can start documenting it piece by piece together with the agent to create this kind of context, to create this kind of information as you go with the flow. You don't need to do a full cut, or you don't need to start from scratch. This is really good for brownfield approaches as well. And basically, it's like a search index on steroids in the end. And what is also very, very true for agentic coding is that clear guidelines enable consistency. So you give contextual awareness to the AI, and they use those detailed rules and instructions to understand what you're trying to achieve and which coding standards it should follow. So imagine you're now migrating to Angular 20. There's new coding guidelines. You can feed this to the agent and combine it with your local coding guidelines from your project, and it will help the AI generate code that is very much aligned with the existing code base and organizational practices. Because, of course, there's a lot of guidelines out there which the models are trained on, but your specific case might be different. And this, in the end, will also result in improved code quality, because the guidance reduces ambiguity, and it will lead to fewer errors in the end, a more maintainable code, because now you're actually in control, you're in the driver's seat of what the agent will come up with, and it will also result in consistent output even when dealing with complex or iterative tasks where you don't really know yet what you're building, or you're trying to find the first MVP before you start iterating on that. And hopefully this will all lead to enhanced productivity in the end, where you save your time by relying on the AI to produce the code that adheres to your standards, and also enables faster reviews and integration of code changes, of course, because you don't need to sift through what the AI has built, and it might be very different from what you expected, but rather you have a very fine-tuned result. And we can really get smarter assistance with something like vector databases as well for your code base. So you could also embed semantic indices in your agent as well, by converting source code into context to have a very fast and relevant retrieval. So think about RAG again, or think about embeddings. This is a very cool thing. And you can have this context extraction and in-context learning by implementing project-specific data into the AI model by whatever means necessary. And nowadays, we can even have live data. So live design data, for example, when we integrate MCP servers, the assistants are now able to pull up-to-date information about pretty much anything. In our case, we will talk about how to pull up-to-date design tokens from Figma and component information to ensure that the code really reflects what is currently going on. And now I already mentioned MCP servers quite a bunch of times. So let's talk about what they really are. MCP servers as a concept are a centralized middleware that connects, for example, design tools with code editors, but everything else as well, really, because there is structured way of serving data as a contextual foundation for AI-powered code generation or text generation, Gen AI in general. And they automate the extraction and normalize this abstraction in a way like USB-C does for computers, right? So it's one standard out there. So it's like USB-C, but for AI. So really, it's a very standardized way of retrieving information from any other tool, rather than having specific tool adapters. We now have this one way of providing any agent with this context retrieval mechanism. And how it works is actually pretty simple. So you might be surprised by how simple it is. So taking our example here that we want to achieve, we can extract design tokens that live in Figma, where they create components, define tokens, where they really just do anything to come up with the component library in the design. And the MCP server will then attach itself to Figma's API to normalize it and have a way of extracting data from there. And it also stores version metadata. So it can reason about, hey, do I need to update this? Are there any changes? What does the model need to know about it? And it will then expose API endpoints to something like Visual Studio Code, for example, to access this structured data through a very standardized way. And the code editor then in the end can use any LLM to interface with that. So for example, when you work in Cursor or VS Code, it will integrate the MCP server and let the LLM talk through JSON RPC calls, talk through any other application that is out there and embed this context information into your request. And we will see this in a moment as a live example, which hopefully AI will play along nicely today. But usually it does. And we then end up with a finished Angular component code in the end. So let's see how it works. So what I have here in front of me, I hope, yeah, this looks good. I think everyone can read this. Let's maybe make it a little bit bigger. So you can see I have a very normal Angular project here. It contains a library, it contains Storybook, it contains a folder for my components here. And it has two little specialities that you might not see in every other Angular project, which is, for one, I have my Copilot instructions here, which specifies what am I actually looking at here. So it's an Angular component library workspace, and I tell it what to do in general. So you generate Angular components, modules, services, and so on, using best practices and all of that good stuff. I tell it how to set it up. So you can see this whole repository that I have here, this whole workspace that I have here, I actually generated through Copilot as well. So, so far, I don't think I have written a single line of code in this project. And I also specify a little bit about the working mode. So what do you need to watch out for? For example, different variations of a component should be managed through inputs on the component itself. For example, if you find something like size equals small in Figma, convert that to a property called size on the component that also refers to a specific class in the component styles. So you can see I'm kind of giving the guardrails to the agent so it doesn't run into the typical errors, which really it might not know about or which it gets confused on. And you can see I have a bunch of these rules. It's a very small rule set for now because I just have this demo case here. And I also, of course, have a prompt. Let's take this prompt and for simplicity's sake, I will pipe this through GPT-4.1, which is way faster than the Sonnet models. The results are, and I tell you this up front, so you don't think the results are not as great. These results in the Sonnet models, they are way better, as I have found. But GPT-4.1 is very, very fast, so we will use this for the demo case. For now, the results are still okay, but they're not as perfect as they would be with Sonnet. But so that we don't sit in front of the IDE here waiting for a long time, I will take the faster model. I will put it in the agentic mode. So basically what I'm telling VS Code here is that I'm going to give you a prompt, and whatever you do after that, you're fine. Just execute everything that I'm telling you here. So I'm telling it, let's work on this Figma file, which is a specific request that will connect to the MCP server, or will let VS Code know that we are now accessing the MCP server because I have defined it as a prompt in the MCP server itself. And it will then go to Figma, pull up my design file, which let's have a brief look at that as well. So I have a design file here. I just pulled a component from a pre-built library. As you can see, it specifies quite a lot of states here. And you can also see that the properties in Figma here, they're well defined. So actually the model should be well equipped to reason about what is going on in this component and actually come to a somewhat good end result. So let's see about that, how it comes up with that. I can tell you already, because I don't have a lot of coding rules here, the results are a little bit different every time. We will now see what happens. So let's start the process. You can see that Copilot actually now looks into my prompt right here. It takes the Copilot instructions, which specify what rules it should adhere to, and then it actually starts looking into the MCP server already. So you see set working file. This will let the MCP server know which file we're looking at, and you can also already see that component code is generated, and you can see that what the agent will do here is to actually pull the information from the Figma file in the background. So you can see all of the nice design properties falling out of Figma here, which will let us know about what is the component actually doing, which color codes, for example, is it using, and how can I work with that. And then we'll check the code base, excuse me for that. We'll check the code base for what is already there. Of course, before the demo, I deleted the button component, so it will now come up with an implementation plan right here on what it needs to do. So you see already, because of the information it gathered from Figma, it can now reason about different states of the component and inputs, where it found the size, the hierarchy, icon, state, and so on and so forth. And because I told it to watch out for this as well, in the coding rules, it will also look into hover, focus, disabled, and all of the other states, and it will follow accessibility guidelines, because if you've seen my lovely colleague Maria talk about accessibility, you now know that the European Accessibility Act is actually being implemented in Germany and a lot of other EU countries as well. So why not have this in here right away? And I think, yes, it's already finished, and it created a fully spec compliant button component. Let's see how true this holds up in a moment. And it added a dedicated SCSS file for the design tokens, as well as created storybook stories for all main variations. And it put this all together in a public API. Sorry. Looking at the component code here, we can see mostly it's fine. I want to say probably here, yes, we're missing an import. So let's fix this really quick by hand, because it's going to be faster than actually asking the model for that. And there we go. Am I importing the right module? We have standalone. Actually, let me ask the model to fix that. Fix using Copilot. There we go. And in the meantime, what we can do is check on the other files as well, or does it already have the fix here? Let's see. Yep, accepted. All right, this is looking good now. You can already see it's using the old control flow as well. These are all things we, by the way, could control through these Copilot instructions files, but you can see it already came up with a style sheet here as well, including a lot of the variables it came up with in the design tokens file. So this is looking quite okay. It's looking a bit shorter than my last test I did right before the webinar here. And you can also see it came up with a story. There is a little trickiness in here, by the way, because we're building a button and we really want to show that in the template to test all of the bindings. We need to have a module metadata decorator here. It found that successfully, so that's a very good thing. And you can also see that there's a lot of properties it included, and it used the component story format. And actually, it looks like it could work. So let's try it out. Do an npm run storybook and see what we got. Moment of truth. And again, I hope this output will be pretty good. We have one issue here that refers to the SCSS file, I'm assuming, or maybe even the design tokens file. Could that be true? Button base. Let's see, where do we have that in our project? Right here. Got it. So let's do another thing here and say, it seems like you referred to a piece of SCSS that is not in our code base. Can you fix it? Here's the output of the build console. And I'll provide that context as well. And let's just see if it can figure it out on its own while we wait here for a second. And this is, by the way, what I've mentioned before, right? So there's a little bit of difference in any model really. Well, Claude is really good at not having all of these teeny tiny mistakes where you don't need to be as specific and don't need to give as many guidelines. The GPT models, I usually find that they run into these weird issues a lot. So as we can see right here, almost everything is there. So let me pull the browser over here. We have the button stories right here. A lot of the colors are already right. We're missing our text still, so let's inspect it. What's going on here? We can see that, of course, the old control flow is going to be an issue. Let's just take this whole output here and give it to the model again and tell it something is wrong when booting up Storybook. Can you check if there's a fix? And now you can see where the conductor part comes in. I'll actually be telling the model, I think this might be related to you using the old Angular control flow when coming up with the button component. Here's the output, and the fix should be here fairly quickly, I hope. So let's see about that. And it's already applying edits right there, so that's a good thing. Let's see, did it actually tackle everything in there? Looking quite okay. We have another thing going on here. That's because it threw away ng class here. Let's quickly add it by hand. And you can see this is not perfect yet, right? So we're not looking at a perfect solution just yet. I would have loved to use Claude for this because Claude really is better at these teeny tiny hallucinations where it mixes up things without having the perfect rule set. One more mistake, let it work in the background again. And let's see how it goes. So, all right, so apparently we had some aliases on the inputs. And this is now still looking the same. Let's figure out why. Are we missing anything on here? Oh yeah, it seems like we're missing the text on the button. What can we do? Provide an implementation plan for the fix. So as you can see, we're not quite there yet to be replaced by AI. I still need to give it a little bit of context, which of course, I could also include this in the Copilot instructions. And yes, please apply it. And this would dramatically improve the outputs again. So let's see. Let's keep the changes. And there we go. We now have an actual button, which does exactly what it's supposed to do. We have the different states of the button right here. So you can see all of these things the model, or the agent rather, did on its own. So that's, to me at least, quite fascinating, because in the end, even if this is just scaffolding code, it would have taken you quite a while to come up with all of these things. So think about it that way. You would have gone into Figma, extracted all of it, would have sat down and implemented the code here. But now we're just getting all of this scaffolding for free. And if you're trying this for yourself, please do so, because then you can use Sonnet 4 and you will see that the results will be even greater, because it doesn't make all of those tiny mistakes anymore, and you don't need to give it as much context because it's really just way better at the code reasoning part. Oh, right. This is all for the demo. I know it wasn't perfect, sadly. I had to quickly switch the model because Sonnet is so slow today. Don't know why, really, because I'm using the GitHub model API here. And I would say, Manfred, let me end my screen share here and hop on over to our little discourse.
Awesome. Yeah, so I have some questions for you.
Yes, please.
Because this is all new and really shiny, but I have some questions anyway. So we have seen this MCP approach. So in what regards is it different to fine-tuning a model or to use other stuff like RAG?
Yeah. So this is the stuff I talked about in the beginning of my slides as well. It differs in a way that it's a very standardized approach, right? So when implementing any RAG system, you would have to sort of come up with your own solution every time. Whereas MCP servers, and you know, timing is everything in life. So whenever I released my MCP server for Figma, the actual company Figma, 2 hours later, they also released an MCP server. So this is now something you can just use out of the box. You can even use a hosted version. I'm currently using a local version for it, and you can just attach it to your IDE of choice that supports MCP servers, and you won't have to do anything really for it. So you just hand it a token, and that's all you need to do. So no fine-tuning involved, no building of a RAG system involved. You just drop it in and you can go right away.
Cool. So there are also other protocols like A2A, agent to agent. Can you compare it a bit how it fits into the MCP world?
Yes, of course. So it's a competing protocol from, I believe, Microsoft, whereas
I think it's
MCP
Google,
is.
but
Oh, it's Google? Okay, thank you for that correction. One of the big ones, at least. And MCP is something that Anthropic came up with. I think both have their place, and we don't yet know which will win, to be perfectly honest with you. I just like the ease of use that we have with MCP servers, because basically it's just a bit of code and it's working with JSON. So it's a really nice way that just integrates in everything that we're already doing on a daily basis. So whenever you would like to extend this project, and by the way, my Figma MCP server is open source, so please feel free to send a pull request at any time. I think agent to agent is neither good nor bad compared to MCP. I think both have the right to be here because we're still finding the right way forward.
Awesome. So what's the future? Do you think all of us will implement an MCP server for their applications?
I could certainly see a future where applications that we build today, they have at least some kind of front end, which could be an MCP server to talk to agents. I think it makes a lot of sense that most software becomes agentic today, because why not, right? So you could just use the LLM to talk to any application that's out there. Let's say, for example, you want to book a ticket with the Deutsche Bahn. You just tell ChatGPT, hey, here's my travel itinerary that I've planned with you before. You know where I'm going on vacation. Can you find the best and cheapest tickets? That would be lovely, right? So I think that would be, or would make for a great future. So if you want to do something useful in AI today, tinker with MCP certainly, because it will enable much more use cases, and it will quickly enable you to also open up new AI use cases for the products you're building.
Awesome. So is this all production ready yet?
Depends on how you look at it, I want to say, right? So you remember I said before that we're still the conductor for the orchestra, right? So you could see as I worked with this generated code, and again, I used a little bit of an inferior model, I really had to help it out in a place or two. You can take this to an extreme and just say, I don't know what's going on, please fix it on your own. And while you're doing that, explain it to me. That would take quite long, so I didn't do that in that demo, but this also works. I think for code that is not security relevant yet, so maybe don't write your payment gateway or your login server with agentic coding software just yet without knowing what you're doing. I think that we shouldn't do, but coming up with these components and just working with the agent to fine tune it, right? So I could now step into it and say, hey, I'm missing this hover state over here in this very specific constellation. Could you go back to Figma and check how we could implement this? I think this is already production grade, because as you work with it, as your guidelines get better, the outputs will only get better and better and better.
Cool. So with all of this, what will be our role as developers in the future?
I think, so I always make this comparison. Not too long ago, there was programmers out there that said, oh, I can't trust anything that's on the internet, right? So this was something like 20 to 25 years ago, and people would look at their books and say, well, someone sat down here and wrote a book and really researched this super well because they wanted to write a correct book, and they cannot fix it anymore once it's out there in the world. So I think this is a good comparison, right? It will evolve, and this will get better, and we will see a point, I think, where 80 to 90% of the manual work involved in coding will be replaced by agents, because in a world where these models make less and less and less mistakes, right? You saw that I only had to fix 2 or 3 mistakes that were minor mistakes, and the model knew right away what I wanted from it. And with Claude, you mostly get the one-shot solution, so you don't have to fix anything afterhand. I think we're just a few months away from doing a lot of the coding in an agentic way. So our role in the end, I think, it will evolve. It won't replace us, right? So probably you're not gonna sit down and think about as much of the actual coding part anymore, but you will think about what is the architecture? What are the right coding guidelines? How can we, or when should we split this up? When should we modularize, or when should we pick one idea over the other? The only thing where I'm not quite confident on giving an answer yet is what do we do with the junior developers, right? Because they need all of this experience by doing the manual coding, or maybe are they learning so quickly nowadays with AI because they have an always on 24/7 tutor that they will jump, right? So, and they will move more quickly to the architecture topics, because I don't know how it was for you, Manfred, but for me, it took quite a while till I got to the point where I could really reason about architecture and say confidently, this is right or wrong, or these are the implications that we're looking at right here.
Yeah, having a good sparring partner is for sure awesome and accelerates learning, of course.
I would agree, yes.
Okay, cool. So there are some further questions in the chat, but before I will come back to those questions, let's quickly talk a bit about your workshop. You have prepared a whole workshop on this topic here. Can you tell us what this workshop is about?
A lot more in-depth. So what we did right here is just scratch on the surface to illustrate a few concepts. In the workshop itself, we will dive way deeper, because then we will have the time to actually compare the models, compare the outputs, and talk in depth about strategies, how to guide those models, talk in depth about what can I do today to make it work in a great way. You will also get a little bit of insight into prompting frameworks and basically everything you need in your tool belt to implement this in your project today, with the outlook of how might this look tomorrow and what do I need to prepare to stay on top of things.
Nice. So here I have this workshop website. Basically, it's Angular Architects with this guy here. But if you switch here to English, you can also do it in German and scroll down a bit. You see this little tiny nice robot. And if you click it, then you see the workshop with your Yauf picture, I guess. And then here we see the modules. So can you tell us a bit about all of those modules?
Absolutely. So we're going to first talk about all of the fundamentals that go into a design system, because I think this is still important, right? So design system and component library, I kind of use this interchangeably because, it it really is almost the same thing. So we will talk about how to set this up. And then when we talk about leveraging AI as a game changer is where we really go in depth, where I said, let's also talk about all of the fundamentals that go into that, like prompt engineering, like prompting frameworks, like setting up your project in the right way. And then we will dive right into a practical application and hands-on learning, where we will actually try and work with this, find what works and what doesn't work, because it's really quite funny since all of these models are trained to behave like a human, think like a human. Results can be wildly different by only having a 2-word difference in your prompt. So we will try to learn together how to prompt in the right way to get the results you're actually desiring. We're looking at some best practices as well. So what can and should you do? And then we're going to have a good old campfire discussion, because I really like exchanging all of the experiences of my workshop participants. I really saw a great response in the past with that. So I really love to have open conversations every now and then to see how is this for you today? Like, can you actually use it at your company? What are the pros and cons? What are your learnings? And are they even still correct today? Because it's changing so quickly. Can we maybe debunk some of the myths that are on your mind?
Awesome. Cool. Okay, so let's come back to the questions in the chat. So
Yes.
Oz was asking, can it convert existing pages created by a designer, a human designer, into an Angular component, template at least, not just variable names from Figma, but the whole page?
So if I'm getting this question right, it's about taking a page that is already coded and out there, taking it into Figma, and then out of Figma again into Angular. Somewhat possible, but not a great experience. You can use Framer, for example, for cases like that, which also offers some of these use cases, but there's no perfect and easy way today, and let me emphasize today, to just take an existing page, carbon copy it, and have it converted. But every well-kept Figma file that contains components and all of the variants to that will work quite good.
Cool. I guess because Figma has all those information in a well-defined structure,
Yes.
and not in this free text form, like a table can be anything on a website.
Exactly, and further than that, Figma really did a very great job in the past at staying close to code, because it actually comes from people that love coding. So the architecture behind Figma itself, it revolves around JSON structures. It really is close to code. That's what I've been telling everyone the last 5 to 6 years about Figma. Please use it, because it's so superior to other design tools, because it thinks like a coder. So it will really help with that.
Cool. Would the AI help be same as the jump from writing assembly application to using an IDE and code completion?
It's a very nice comparison, and I would say, yeah, probably, because what I try to refer to is also, and it's a very similar example. You know that, and I think it's a more fair comparison. You know that we're all writing Angular. Why are we not writing WebAssembly in the browser, right? Because it's just so much more convenient to have all of these APIs already in place, to have someone sitting there that's actually taking all of these considerations for ourselves. Or we could be writing vanilla JS, but still that's kind of annoying, right? Because you need to build all of these things that are already pre-built. And I feel like it's a little bit like that, but also there's so many more possibilities, because Gen AI in theory can do anything. And there's a few cases that it's already pretty good at.
By the way, I really like this metaphor for another reason, because back then, when assembly was still a thing, and when newer programming languages came up, some people said, no, I don't use those newer programming languages because I'm a pro when it comes to assembly, and they will never, ever be capable of writing more efficient code than me. But nowadays, this is rather the rare exception than the usual thing people are doing. So perhaps we should really take care here to not miss the train.
Yes, that's what I'm trying to raise awareness for in the end, right? Because of course it's not perfect yet, and we've all seen that. We've just seen that in my demo, but it's not going to get worse from here. And I also still remember a lot of people telling me for a very long time JavaScript is not a programming language, and it's now running something like, I don't know, 80% of business code that is for web applications, right?
Yeah, correct. Marcus also wrote he is still remembering guys refusing IDEs in the days, back in the days. Yeah, so perhaps Marcus studied in Graz. So there was, I think, one guy who forced their students to use Emacs or something like this. Okay. Yeah, Vim is still a thing, but special interest.
I mean, it's not like you cannot do things with Vim or assembly, right? There's still cases where this is great, but
Totally.
yeah, for other cases, it might be a lot easier to just use an IDE or whatever.
Thanks for sharing. The Figma MCP Angular is what we are trying within the next few weeks because we hate pixel pushing. Yeah, I feel you.
Yeah, I hear that quite a lot. And I'm so happy that I can finally give a confident yes to, is there a way of automating this, right? So this only took us something like 25 years to get to this point. But I'm super happy that I can now say, look, even if you're a back-end programmer, just go ahead and use this. It's gonna look fine.
Mm-hmm. Yeah, and people still use Vim a lot. Yeah, I don't want to trigger a war here. Don't get me wrong. So I know there is a huge fan base and you can be quite efficient. Okay, but can you just draw Figma pages with some instructions included and then transform it to some working components and even working pages?
So Figma is actually gradually rolling out more AI features as well. So even if it's not activated on your plan just yet and it doesn't work great yet, I would expect this to become a thing in the very near future. So this use case absolutely makes sense, and there's already tools out there that can do exactly that. And again, this will become a thing. I'm highly confident about that. It will become a thing, and it will be the same thing for designers working in Figma that it will be for us programmers working in VS Code. You will rather specify what you want to have as an art style and what components you need, and then you will let a lot of generation happen, actually.
Mm-hmm. So what's the price of doing this? Which licenses do you need?
The MCP server itself, and by the way, let me post a link to the chat because I didn't do that yet, I think. It's my open source implementation of it. You can use it for free, and I cannot post a comment for some reason. Let me send it to you in Slack, Manfred, so maybe you can post it in a minute here.
Oh yeah, sure. Just send it over.
This is free. You can also, in theory, I think, use the free Figma version. I'm not 100% confident about that, but you can use the most basic plan in Figma and experiment with this. And the cost for the coding assistant is whatever coding assistant you want to use. For example, what I'm doing here, because I know this is a big topic for most people, I used the cheapest version of Copilot, which is the free version, by the way, so no cost involved. So if you sign up to GitHub, you can use GPT-4.1 and it will present those exact results I just showed, because I want it to be realistic. If you want to use Claude 4 Sonnet, like I referred to before, it's $10 a month over GitHub Copilot, or you can use any frontier model with any other tooling that is out there. So it's really a from to. In my everyday work, I use AmpCode, which I think AmpCode is a fantastic tool, which does a phenomenal job at these tasks. So it's way, way better than what we just saw. But it's also quite expensive because you're paying per use. So for example, the MCP server itself, it might come as no surprise. I didn't write a line of code myself. So I built this MCP server fully through AMP code, and that took me about, I think, $30 to write the whole MCP server repository, so you get a feel for it.
Mhm. What advice could you give to the designer who does not develop but only draws in Figma?
Start developing. Now's the best time. You actually don't need to know anything about development. You can just hop right in and educate yourself, because I think in the future we will not have these very singular jobs anymore, right? Because now it's so easy to do multiple things at once. So whatever you're interested in is now very much in reach, and I think it makes a whole lot of sense that we become more generalistic workers in the future, right? So all of the knowledge workers will have to be a little bit more generalistic rather than super specific like today. But this is my guess about what I'm seeing so far.
Essentially, how can the designer work towards improving Figma's usability for an AI agent?
This is all about providing structure and documentation again. So the more well-specified components you have, the more documentation you have inside Figma as well. For example, and I didn't even show that today, you can also add description in Figma, and the agent will then pull that as well. And you could write there that this should be an interactive component, or it connects to another component, and you can create even more hierarchies there and even more context for the agent. But it's all about giving a well-structured way of providing the information, because a big Figma file without any components and thousands of layers, that won't work well. It won't work at all, actually.
So have you encountered model accuracy degradation because of chat size exceeds model's context window size?
Yes, that's why I regularly start a new chat. You might remember that I referred to an agent MD file before. So this is kind of the context keeper. I provided in my instruction set as well. I tell the agent to, every time you do something, do two things: persist it in the agent MD file and also commit. So I can easily roll back in Git using the history, so that whenever it does a big fuck up, excuse my French there, I can just easily roll it back and also use the Git history to figure out what is going on. And the agent MD file basically looks like a big task list where the agent just crosses off, okay, this is now done. Here's how I implement it. Let me give you the quick rundown in basically 2 lines of text where I tell you what has happened and how I implemented it. And this really solves a problem for me.
How much do you consider to invest in learning new models? Do you have some newbie, medium, senior recommendation?
This is a super interesting question, because I think before you even start learning the new models, you have to bring yourself to accept one fact. And this seems super hard for every programmer that I've met so far. Forget everything that you know. Assume you know nothing, because you're going into a new domain, right? So if you start working with a model for 5 hours a week, for example, but you're doing the same thing over and over again because you say, well, this is how it should work, I want it to work in that way, it will get you nowhere. But if you're being as humble to say, okay, I know nothing about this, let me learn it just like a programming language, for example. What are the right prompting frameworks? How do I use this? Now, this didn't work out. Why didn't it work out? Let me find information on the internet on that, or let the model explain it to me so we can explore it together. Once you have this degree of humbleness, I think 5 to 10 hours a week really gets you a great deal of experience and information, and you will start to use it more and more every day, just because it solves more and more tasks. I myself dedicate about these 5 to 10 hours a week. And then there's all of the times where I'm waiting for the bus or something, and I'm looking at my phone, checking what's going on Twitter, and basically trying the newest things that are possible and available.
Can you host the MCP server locally? How much graphic card memory would be required?
So maybe one important distinction here, the MCP server is just a layer in between that's dispatching from one tool to another. So I was running it locally, and it is super resource efficient because it's just a node server providing some API endpoints. If you want to run a model locally, you better have a very beefy MacBook because running models locally is super expensive still. It's possible, but I wouldn't recommend it. So running this MCP server locally is as easy as checking out the GitHub repo, building it and running it. And it will run it next to no resources.
And Stepan is asking how it will break that development flow. You will write instructions and maintain not the code itself, but the instructions.
It's a scale, right? So I don't think it will be a switch overnight. As you can see, we still have the typical errors that we're finding, but it's getting better. I personally think that, again, about 80%, I would estimate, of the writing of actual code, writing it by hand, would be replaced by this. But again, this is a guess based on the last 3 to 4 years, what I've been seeing in terms of progress. But it's very, very hard to say today, right? So if I knew that, I would go into the stock market and short some companies, but I really don't know it. So I can only give you a best guess. I think it will be a very integral part of how we write code in the future. That's what I can say.
The Digger Lily is asking, can you please elaborate on what tools you use in your day-to-day?
It's quite a bunch because I keep switching between tools because I find some work better for some use cases and others for other use cases. What I really, really love is AMP, which is a plugin for your favorite IDE. So it's ampcode.com, I think. They also have a free credit tier at the start where you can just toy around with it as well. This is one of the best coding tools, agentic coding tools I've seen so far. It's absolutely amazing. It every time a tool blows my mind, 2 weeks later, a new tool comes onto the stage and blows my mind again. What is also really good for most cases is VS Code. It's really quite well kept. It doesn't cost any extra money. If you want to invest a small amount in having some of the best tools out there, I would recommend Cursor, just like the mouse cursor. It's also an AI-first code editor. It provides a lot of convenient tools like code search, doc ingestion. It does a lot of the things that that you can do manually. It does it as part of the IDE, basically. So these are the 3 main coding tools I use, and I, of course, every day use ChatGPT. I use Lovable. I don't know if you've heard about that yet, Manfred, but this should also be great for you because you can come up with a UI for demos where you just prompt and it will spit out a nice piece of UI. I use that quite a lot to prototype ideas because really it's just not worth for me to jump into Figma anymore for any prototypes. And probably like 50 other tools that I can't recall from the top of my head. So I do quite a lot of stuff with AI already today. For example, I also record, or not record myself anymore. I use HeyGen to use a digital avatar of myself to transport information. So I can just write it down. I don't have to have well-kept hair. I can sit anywhere in the world. It's always going to sound and look the same. So yeah, I use that as well.
Mm-hmm. Awesome. So Andreas, big thanks for all those insights. It was really a nice presentation, nice demonstration, like nice example, but also it was nice to discuss all of this with you. I see there is one last crazy question from Radu. Would it be possible to add as a resource the clean code by Robert C. Martin to book the flows?
Shall we do a quick live test of that? Because I have an idea in mind how you could do that. So let me share my screen again really quickly. I don't know if it will work, to be perfectly honest, but I want to try it out. So,
this is the right screen, yeah.
Yes,
so
you
I
can now
could
see VS Code.
imagine that the the model already knows what clean code is.
I would think so as well, but let's make it a little bit more exciting. And say, can you take the best practices from the Clean Code book by Robert C. Martin and persist them in a file called coding guidelines .md so that we can refer to them while writing code. Make it so that a model or agent can easily consume it. See how that goes.
Make it so. I like it. You know, Captain Picard and the Enterprise.
Yes. I recall. You're a Trekkie. So you can see here, this actually works quite well, right? Because it has all of the information baked right into the model. So you were perfectly right, Manfred. And now you know my biggest secret, right? I don't think anymore. I just let the agents do their thing. In most cases, what I just showed here works really well, right? So you have an idea and you say, let's put it into this file. Please make it so that the agent can easily consume it. And you could even ask follow-up questions like, what do we need? I always refer to the agent as we, by the way. So it's the agent and me. What do we need to do to make this consumable for VS Code agent, or sorry, GitHub Copilot agent is actually what it's called. And then it will take this file, of course, and make it consumable in a better way for it. And then you can just move it up to the .github folder and refer to it. Go ahead and implement the changes. And there you go. You will have a very quick version of how to make this easily consumable for GitHub Copilot in your IDE, baked right in there. And then we press keep, move it up there, and now we can just refer to it every time we're writing code, and it will just do exactly that. And you can also do things like use DRY and Yagni principles, so the code is also working in a ThoughtWorks way, right? So there's a lot of things you can do. This is what I was referring to, but try to keep this a little bit slimmer for this demo right here, so it's actually understandable.
Yeah, cool ad hoc demo. And I'm really looking forward to my old days when I can tell my grandchildren that back then in our time, we had to do all of this by hand. We had to read the books and to apply the knowledge from there by hand. And I think they will make huge eyes, you know, oh, this was the Middle Ages back then.
It will be funny, right? It will be just like our grandparents that told us that when they went to school, they had to walk uphill both ways. But really, this is how it is, right? And maybe I give the question back to you because I would be interested in your take as well. What do you think? How will people learn to code in the future, and how will they code in the future? Will they do it the same way that we did and try to read up on it and do their experiments and see how it goes? Or do you believe that the future is in those coding bootcamps that are already happening in the US, where they give a model and a PC to children and they do vibe coding to learn about this?
Well, I'm not sure if they will start with vibe coding in the very beginning, but as you mentioned before, I think all of us will have their private teacher, which is an AI that will help us on a regular basis. And we can ask them questions on a regular basis, which is not the case in a traditional classroom setting. And I think this will make everything more easy. So we can learn more in a shorter time, I guess.
I highly agree with that. I just posted one more video to the chat here. It's about an 8-year-old girl that uses Cursor to come up with her own Harry Potter make a spell application in, I think, React, which I thought was quite fascinating. And this was already 9 months ago, right? So it's quite fascinating what is already happening out there. When you have a very open mind, you can do a lot with it already. But I think sometimes it's hard for us all to open our minds to that, just because we're so used to how we work today, and it's hard to accept the fact that everything is probably about to change, right?
Yeah. Awesome. So one more time, big thanks. Don't forget about the workshop if you are interested, and yeah, see you around. Thank you. Bye-bye.
Thank you. Bye.